Chapter 28, Current and Resistance. So Chapter 28 and 29 really go together in that our next chapter is going to be electronics and circuits and components. And Chapter 28, this current and resistance chapter, really is going to introduce us to, for this course, the most fundamental description and understanding of the flow of electrons, the flow of charge in wires, what resistance means. This chapter would really be the jumping off point for a course in atomic and molecular physics. So we're not going to go quite into that level of detail, but just above it, and we'll understand current density, the number density of charge carriers. So we're going to introduce a lot of language and variables that we'll use then at a much even higher level when we do our circuits and circuit theory in our next chapter. So let's see what we have. Current, as it says here, is the flow of charge, and specifically for us, always conventional charge. So as we had said before, we are really looking not at the flow of electrons, but at these kind of pretend positive charges flowing in the opposite direction. That is our conventional charge. We will always work with that. So it's the flow of charge. And notice it's the flow of charge, not the flow of electrons. So it's the charge value, the Coulomb value. So let's jump down here to our definition, our 3 equal sign. So current is going to be defined by the coulombs per second flowing through a wire. And that value, coulombs per second, is given the term amperage or amps in honor of André-Marie Ampère, who did much of the fundamental mathematics and experiments understanding the flow of charge, the flow of these electrons. So resistance, as it says here, so let's get our notes all up to date and annotated. Resistance we're going to think of as what the name implies, resisting the flow of charge, and we can think of this as electricity friction. I have friction in quotes. And it is going to generate heat, just like mechanical friction generates heat. So again, please make sure you get all of these annotations down. And in our introductory page here, we have one last bit to discuss, and that's to kind of get our minds thinking about the flow of charge in this very atomic and molecular way. So we have a circuit set up here. So what we're looking at is a blown up region of the wire, right, coming from the positive terminal of the battery. And again, that's our high voltage terminal. The negative terminal is, of course, always the 0 volts or ground voltage. And we will be always following the flow of conventional charge, these positive charge carriers going from positive to negative, pushed by the battery, and we think of the battery as doing that pushing through voltage pressure. So it's this pressure pushing these Qs along. Now, again, for completeness of our notes, get the electron current in here will be the actual electrons flowing in the opposite direction. And the last thing to put in here, again, just for completeness of our notes, and we're going to talk more about this in the chapter, is that the actual flow of electrons, and consequently the charge that flows, is going to be very small in wires and the electricity that we think of as electricity in our houses. We're going to see that flow is actually on the order of centimeters per hour. And that's why the speed, the actual meters per second of speed that we talk about when we give it a variable name will have a little d with it. The d is for drift. So here, if we want to kind of put it in here, drift. So it's the drift velocity is the actual velocity because it is so slow. So that's our introductory page of notes. Of course, and I kind of skipped it here a little bit, we'll have a non-calculus or average flow of charge, and we'll talk about a calculus instantaneous flow of charge in this chapter as well. But pause the video, make sure your annotations are complete.